Hey AI agents, welcome to my channel Artificially. Today we are talking about Deepface. Deepface is probably the best facial recognition and facial attribute analysis tool that works with Python. With Deepface, you can recognize faces, extract features like age, gender, race, etc. on images or videos for faces, and it's really easy to install using pip. But if you install it using pip install Deepface, you will miss one very key attribute that can make or break your application when you are developing a face recognition or facial attribute analysis tool using Deepface. And this feature is hidden from the pip install version of Deepface. Deepface has a secret weapon, so let's reveal it. What makes Deepface stand out is that it's a hybrid face recognition framework that wraps around the state-of-the-art models from various sources, including VGG Face, Google FaceNet, OpenFace, Facebook Deepface, DeepID, ArcFace, DLib, and SFace. This allows it to be highly accurate and reliable, making it an ideal tool for various face recognition applications. You can even run ensemble of models to get best accuracy. And you have this YouTube channel from the author of this GitHub repository, and I recommend that you watch his videos to learn the basics of the library. One of the most impressive features of Deepface is its ability to recognize and analyze facial attributes such as age, gender, emotion, and race recognition. This can be very useful in fields like marketing and advertising when understanding the demographic of a target audience. In addition, Deepface can be used to analyze facial expressions and emotions. This can be particularly useful in the fields like psychology and customer service, where understanding the emotions of individuals is important. However, if you install Deepface using pip or conda, you will miss a very important attribute that is baked into Deepface, but it's hidden, and that is the confidence score. In a face detection or face recognition task, the confidence score indicates the level of certainty that the machine learning model has in its prediction of whether a given image contains a face or whether a given face matches a known face. This score is a measure of the model's confidence in its prediction, which is typically represented as a probability value between 0 and 1, but that is not set in stone. Depending on the face detection model, it may vary. The significance of the confidence score lies in the fact that it allows us to control the trade-off between precision and recall in our model. In other words, by adjusting the confidence threshold, we can choose to be more or less conservative in our predictions, depending on the specific requirement of our application. For example, if we are using face recognition to grant access to a high security area, we might want to set a high confidence threshold to maximize the risk of false positives. That is, allowing someone who is not authorized to access the area restrict their access by being more precise. On the other hand, if we are using face detection to identify faces in a large dataset for research purposes, we might be willing to accept a lower confidence threshold to increase the recall of our model, that is, capturing as many faces as possible, because we don't need to be as precise in this case. Overall, the confidence score is a crucial component of any face detection or recognition system, as it enables us to fine-tune the performance of our model to meet specific requirements and optimize its accuracy for the intended use case.